Okay, how did I build this? So I started off looking at, and looking at the one that was given in the Texas Instruments, and then just tried to model it. I started off with the grid turned on, and I had a little bit of, a think, and thought, well, it's probably going to be easiest if I have, given that the thing has a line of horizontal line of symmetry, to put that at y equals 0, and to put the nose of the thing at 0 is probably going to be the easiest. So given that, then, okay, I've rearranged them slightly here, but this is roughly the order I thought through the bits. So first of all, I'm going to put on this line that's a scale, was the first thing I put on. So if I create a list of points, one way of drawing lines in Desmos is to create lists of points and have it connect those points. So I've got a point at 0, -6, and a point at 10, -6. Okay, putting square brackets around things makes a list. So that's a list of, you can have a list of numbers or you can have a list of points. In this case, it's a list of points, list of exactly 2 points. Okay, by default, when, oops, I get it to come up. I'm doing it with my left hand and I'm pretty good. By default, when you create a list, the lines are turned off and the points are turned on. In this case, I wanted the line turned on, and usually I turn the points off, but in this case, I think it made it look a bit clearer just to leave those points turned on, a bit like those little vertical lines at the end of the scale. So I left the points turned on, but I turned the lines on and chose to put it in blue for whatever reason. That's a straightforward way of drawing a line. Okay, then I wanted to put a label on that. This is a function I end up writing in an awful lot of these things just to find the midpoint of a line, midpoint of a list of points, strictly speaking. So I've written myself a little function called mid that takes a list of points. Just a little convention I've developed for myself is I tend to use capital letters for lists. So in this case, it's a list of points, and it will take the mean of the x-axis. The mean of the x coordinate. So p dot x is the x coordinate of a point. When you go dot x, you get the x coordinate of a point. And if you take a list and go dot x, you get a list of the x coordinates. So that generates a list of the x coordinates. And then find the mean of those. Same for the y coordinates. And find the mean of those and put those in as the coordinates of another point. So this thing is going to end up returning a point. That's the mean of the x coordinates and the mean of the y coordinates. Which, when you've got two coordinates, gives you the 2 points. When you've got 2 points, that's going to give you the midpoint. So then I take the midpoint of my original list, okay, and turn off its point, turn on its label as 10 meters, and write that underneath. Bingo, I've got my 10 meter scale. Then I created a variable for b, and I set it to go from 0 to 10 as the values it can take. Create a point that has an x coordinate of b and a y coordinate of -5, so that's my orange point here. And because b can't go smaller than 0 or greater than 5, that's constrained to go between smaller than 0 or greater than 10. That's constrained to go between 0 and 10, so my point can't go any further than that. Okay, and then create another slider, just the same, another line, just the same as the blue one, but instead of going to 10, this one is going to B, wherever B is. And again, create its midpoint and label that as B meters. Except I've got a typo, haven't I? I just noticed that. Oops. Okay, then creating the body of my fish. Okay, so I want to create another list of points. I did the body in 2 parts. I could have done it in 1 part, but I could have done the whole fish in one thing, but I divided it into the body of the fish and the tail of the fish. So I've created a list of points that makes this square. So this point is 0, 0. The third point is going to be at B0. And then this point, the second one, is going to be at half of B, negative half of B. And the fourth point is going to be at half of B, half of B. So we go 0, 0, B over 2, negative B over 2, B0, B over 2, B over 2. Okay, so that's a list of 4 points. And I've turned off all the dots. I could have left them on, but I thought I'd turn them off. To not have those dots was nicer. And then to actually create the square from that list of dots, I just go polygon. Polygon is a function that if you hand it a list of points, it creates a polygon of those points. And you can choose whether you can switch on and off, obviously, but you can choose whether to fill that polygon or not. And you can choose whether to turn the lines or not, for that matter. You can turn the lines off if you want. If you turn the fill off. Okay. So that created the body. Next I wanted the tail, so I wanted to work out the height of this point, which I figured was 10 minus b, because this distance, that's at b, that's at 10, so this distance is 10 minus b, so this distance must be 10 minus b. So the polygon for this was b0, 10 negative th, my variable, 10 positive th, and it's only got 3 points, so it's a triangle, and then polygon that to create that triangle. So now I've drawn my fish. Then I wanted to put in this like spine of the fish. SP came from, oh, well, that looks like the spine of the fish. So that's another list of points from 0, 0 to B0. And turn on the line. And I made it a dotted, this one a dotted line, just because that's what was in the original, or a bit like a dotted line anyway. And then find the midpoint of that line, turn on its label, and the midpoint I wanted to set to be B equals, and then I want the value of B. So I get the value of B by going dollar, curly bracket, B, close curly bracket, and then the M for meters. So that labeled this, and again, I set it below the line. Okay, nearly done. Then I needed to so the last thing to do was to write the area of my fish. So I wrote this function to calculate the area. Area of a square from its diagonal is half of b squared. And then like this was my working out of what that was going to be by figuring out that it's half of a square of twice this. Okay, and I didn't bother to simplify that. I don't know why I left it as a fraction. Doesn't matter. And then I wanted to write that somewhere, so I create another point. And I think in the version I sent you, I still had the dot turned on and things. So in this case, created a point at 1, 6, turned on its label, and I'll actually, I've left it at the moment with a more complicated version of the label. I was playing around with the best way of writing out the label. The version I gave you was done rather more simply. In order to get, I think the version I gave you was something like, let's just create another one at 1, 5, was something like, oops, go away. Total area equals, okay, then the variable, so dollar, curly bracket, I called my variable area. You can, I don't know if you figured out in Desmos, all your variables are just a single letter, but you can have as much, so as long as subscript as you like within reason. So area, that underscore is like the subscripting. So dollar area and then meters, and I wanted that squared to come up the top, so I need backticks to mark that as LaTeX, like that. Okay, so that's kind of that. I think is fine, and then turn the label off. Sorry, turn the dot off because I don't really want the dot, and I was going to put that to the right. I think I forgot to do those in the version I gave you. I was then playing around with, could I make it look a little bit more professional? This 2 being in a completely different font in the math font rather than the normal font was kind of bugging me. Excuse me, I've got the hiccups. It was bugging me. So I was just playing around with, okay, what did I need to do if I wanted that to format that a bit more nicely? Let me just take a copy of that one. And now, if I just put that whole thing inside LaTeX, so it's all formatted as math, like that, I've got a problem. I don't overly like the thing being in italics, this being in italics. Because it's math, it doesn't do spaces where, it puts spaces where it thinks the spaces should be for maths and things. So if I do that, I've then got to backslash that space in order to get a space. If I don't, maybe I don't really care whether this is in italic, but the other thing that really bothers me is I've lost my space here. There should be a space between numbers, and I'm a bit pedantic about this, but I think as maths and science teachers we ought to try and get these things right, in the same way that as English teachers we should try to get punctuation and things right. As math teachers and science teachers we should try to get unit things correct. Okay, and in the metric system, the SI definitions and such are quite clear. There must be a space between the number and the unit, and unit symbols must not be in italic, because M in an italic M in the SI system is a dimension. of mass. And I don't want a dimension of mass. I want a unit of meters. That has to be an upright font. I can get it into upright font by going \math rm for Roman font around curly bracket around that M. So that puts the M back into Roman font. And then in this one I did the whole thing. You don't kind of need to worry about that really. That was just me figuring out how good I could get it. This one I think was fine. Rest of it's pretty straightforward really. Always happy to have a go at them. Always happy to talk through how I do them. Hope that helps. If I've assumed something that you don't already know, so you don't get something or something's not clear, please ask. And please carry on asking the questions. I enjoy doing this. It's fun.